Hi, my name is Sylvia, and I work for the public engagement with the research unit at the University of Southampton. And welcome to the second episode of the SOTSEF chat. And today our guest is Dr. Alex Dickinson, that will talk to us about PERSO, from bench to bedside. So without further ado, I'm going to pass the word over to Alex, and I will start with some very basic questions before we can take more questions from the people attending. So the first question for today, Alex, is can you tell a bit or a lot, as much as you want, about yourself and the research that you do and your research, the role that you play with PERSO?
Well, thanks very much for the invitation to speak to you today. My name is Alex Dickinson. I'm an associate professor in the mechanical engineering department here at the University of Southampton, and I work in the bioengineering science research group, and the lecturing I do is generally in engineering design and some computing aspects too. My research is mainly about prosthetic limbs, and I'm particularly interested in how we design the patient-specific parts of the limb to fit the individual. So a lot of the time we focus on the fancy mechatronics or the visible bits of the prosthetic limb, but actually the customized bit that you use to attach it to the person often is the simplest bit, and it's the bit that has the greatest importance on how comfortable and how functional the limb can be. So those are the kinds of things I normally do. But you've asked me to talk today about a completely different project that came about rather unexpectedly in the beginning of March, which is this PERSO project, and that's rather different.
So well, let's carry on with the first obvious question. What is PERSO?
So I've put a few pictures together to share this. So hopefully once these load, you'll see. So PERSO PERSO stands for the Personal Respirator from Southampton, or Personal Respirator System. And really importantly, although I'm doing the talking, I'm talking on behalf of a really big team who I'll show at the end of this session. I'm just one person here. On the evening of I think it was Monday the 16th of March, I received an email asking if I wanted to get involved in this project. They were looking for some can-do engineers because they'd identified a potential problem, and they wanted to try and tackle it directly as academics in Southampton. And what I'll talk about here is really how that unfolded and how we developed a series of concepts into something which our healthcare workers are using in University Hospital Southampton now. So in early March, The Lancet published an editorial where they described all of our healthcare workers as every country's most valuable resource. And I don't think anybody would really disagree with that on the basis of what's happened in the last 4 months. We've seen, unfortunately, though, reports that 1 in 5 healthcare workers treating COVID-19 in some countries have become infected. And in some countries, that's made up to nearly 1 in 10 of the country's cases have been the healthcare workers actually treating the pandemic. And this is obviously something we have to avoid for those healthcare workers, just because we want to look after them. But it's a vicious cycle of a problem, because if the staff become ill themselves, they become absent, and then less able to tackle the pandemic. Now, in a pandemic with a new disease like this, or where we don't currently have a vaccine, personal and protective equipment is a crucial part. And at the beginning of this pandemic, PPE was in really quite short supply. There was international evidence that healthcare workers don't always have that much training or provision of PPE before pandemics. And a potential problem here was, especially where we didn't have a really well-functioning test at the beginning of the pandemic, you'd have people who'd had negative test results being treated on standard wards by healthcare workers who didn't have any PPE or high-level PPE. So PPE was already quite a hot topic even back at the beginning of March. So did we just need lots more face masks? This covers an interesting point where we look at different kinds of PPE and how, although a lot of them look like masks, they're all quite different. So this is the standard surgical mask, which you would see if you were in an operating theatre. And the big difference here, which I think is now being understood by the general public far better, is that these masks are really good at protecting other people from you. So you'd see, especially if I'd chosen a side-on photo, when you breathe in, you're breathing in air from around the mask. So this doesn't protect you from the things you're breathing in. It's just stopping you coughing or producing droplets when you speak, or stopping those droplets from reaching people. There are respirator masks, which, as you can see, have a much better sort of sealed fit around the face, and they have a filter, so they actually filter the air that you breathe in. But they also, in order to be functional like that, they have to fit extremely well, so they can put quite high pressure on the bridge of the nose and around the cheeks. So this is a picture from one of the main influencers on Twitter, who's I think an anesthetics consultant now, and she's reporting what wearing one of these respirator masks does to her face after 8 or 9 hours of a shift. So it can be very uncomfortable. You can get far better protection still if you use what's called a powered air purifying respirator like this, where you have a fully enclosed hood and you have a filter with a fan and a blower system that feeds that filtered and purified air into the hood. But things like this are quite expensive, and what we could see at the beginning of the pandemic was that these things weren't necessarily very available. So we were given this sketch by Professor Paul Elkington right at the beginning. He's one of our respiratory consultants at the hospital, which is essentially it is the concept of the air purifying respirator. But what he was interested in was whether we could distill the concept of the PAPR down into something quite simple that we could make locally, with off-the-shelf components where we had access to them, and with minimally complex manufacturing techniques. Something I think we also had in mind from the beginning was that we weren't the only people who had this problem, and even if we had a worse problem then in March or April, in other places the pandemic would be developing at different rates. And so if we could come up with something that we could share the designs of so that other people could benefit, this would be the best thing we could offer as a university. So within I think it was about 60 hours, we had a working prototype, which I think exceeded all our expectations. So this is a fan, so it's a centrifugal fan, and then we have a HEPA filter. So this is relatively similar to the kind of filter that you might see in a vacuum cleaner or an air conditioning unit. We had to produce some customized components. So these are images of 3D printed parts, which you can use as a duct to somehow feed the air onto the over the top of the head, and other ducts to connect some hoses on the outlet of the fan. We found these brow guards that you use if you're strimming or working in a workshop. So this is a transparent visor and then some headgear. This is a runner's backpack. So we needed some way actually to mount this on the human. And then we had to come up with some sort of a hood as well. So this is one of our first round of prototyped hoods. This is made from roofing felt, but cut with a laser cutter, and then it's got this brow guard inside it. And then later on, we started making prototypes. This is with this is a single-use lab coat, disposable lab coat. You might just about see it's got the pattern marked out on the back. So we could scavenge material in cases of low availability. So just within a week, we had this working prototype. So this is the Perso 1, and so we've got various different version numbers of all the parts we're fitting together. But we took this basic prototype to the hospital to get some user feedback. And I think more or less on the spot, they said we're interested in trying to get hold of potentially thousands of these if you think you can make them and if you think you can develop them further. So we realised it wasn't over. So we went away, and then this is now within I think 9 days of the brief. We put together a second version prototype. So this is now a much more sort of resolved filter to fan assembly with a protective cover, so it's now a little bit safer to use potentially. We had great input from some supporters now, so this was an updated headgear that was designed by the team from McLaren Racing. We also had input from a couple of sail makers locally to help us do better with putting the hoods together. And then we took this updated prototype back to the hospital, and we got some not exactly user testing, not a pilot, because we obviously didn't know it was safe enough to use in people at risk. But we asked users in safe conditions just to try them on and to feel the usability, to understand what might be uncomfortable or which activities it might prevent them from carrying out. Based on that, we went away and learned a bit more, and we realized we needed some more partners. So we partnered first with Indo Lighting, who are a local small medium enterprise who have helped us to turn this into a product, which is now, I think the Perso 3, I think, is the one which is now in use in University Hospital Southampton. The UHS team themselves did a lot of work as well on helping us to develop the protocol to use these devices. I say help us to develop the protocol. They really developed it themselves. As with any PPE, probably the biggest risk is not understanding how to use it safely. So you think you're protecting yourself because you're using PPE, but if you're not using it in the right way, you might inadvertently contaminate yourself and have a false sense of security. So the protocols for safe use and what we call donning and doffing, putting on and taking off the devices, is very important. I think it was the end of April, we were having the first ones of these Indo Persos delivered to University Hospital Southampton, and this is a collection of images from various parts of the press and from people's Twitter feeds of them using them, so you can see a little bit what they look like in practice. And finally, although it's not the end of the session, I mentioned at the beginning there's a lot of people involved, and I'm just one of them. So I think across a couple of projects that have now come out of this, we've got I think there's 18 people involved, several company partners, and we've also had a lot of donations from the general public, who we really have to acknowledge. And in particular, Stefan Cross and Dr. Alison Steele have been particularly generous donors to this, and are helping us to carry out the next stage of the project. So we're very grateful indeed to them. That's about the most concise fly-through I can give, but I understand you have a few more questions. So what would you like to know?
I've been blown away, I'm honest. No, it's so interesting, and to see so many different people coming together, that is really fascinating. And also the feedback that you got from people working also in different sectors, and the fact that you involve Indo Lighting into the project. So you mentioned that one of the peculiarity of Perso is that all the components at the beginning in the prototype came off the shelf. So what is it? Is this one of the main reasons why it's different from what is already available on the market, or there is more?
There are several considerations, I think, that make this a bit different from what's available. And frankly, at the beginning of the pandemic, we were most concerned that the existing devices wouldn't be available. I think I developed my first Twitter troll as well in trying to talk about our first ideas, when we wanted to share the idea and make sure that we weren't duplicating efforts with other universities and companies. A couple of people jumping online and saying, we haven't invented anything. This isn't new. This isn't innovative. So I think we're at pains to point out that it's not a total brand new revolution. This concept of these air purifying respirators is really quite established, and people have been welding in them for a very long time and painting in them. And some people indeed are using them in ambulance services in other parts of the country, and in high intensity units in hospitals. What's different here is that we've made some really specific design considerations in making sure that they can be as usable as possible for this particular group of users. So, for example, the kinds of cleanable material and the lightweight of the components, the way they're mounted on the body, bearing in mind that you're unlikely to need to perform CPR if you're wearing one of the devices that you might be welding in. So we have to prepare for different kinds of use. And then, yes, the fact that we wanted to make self-assembly concepts as simple as possible from the beginning. There are obviously challenges if you're releasing the design for other people to use, making sure that it's safe and you've considered everything, and that they can put it together in a safe way as well. Yeah, those are many of the considerations we had to make.
So I might ask you more question about personnel. And I'm quite interested because it's quite a big thing. So when was the moment that you as a team realized that we can make it, we can make a difference, we can make an impact?
I think I should probably admit I was a tiny bit skeptical at the beginning when they asked me to get involved, because I looked at all of the other devices and I thought, well, do we really need to start again from scratch? Do we really need to begin? And I think once we realized that things were limited, we would need to build this from the beginning. And my main concern was that this is quite a complex system. It's got lots of different components, which require different expertise in each case. And I knew that I would only confidently tackle probably a quarter of the required parts. But I think what reassured me that we could tackle it well was because we're quite unusual as a university in having access to lots of different kinds of expertise all in one place, lots of useful equipment, lots of optimistic approaches to identifying different bits of material that we might be able to use. So I think once the team grew, we realized that actually everybody was concerned about one or two parts of the device, but somebody was confident about tackling each part of it. We had the right team to have a go.
So you told us before about the story behind Person, but what were the key operational challenges in order to bring a device that was designed on a bench in a laboratory into the hospital?
So that's a very broad question, and I think we set off very fast at the beginning with lots of ideas about what we could develop, and I think something very important was recognizing which parts of the normal process of bringing a device like this into users into a hospital were really essential, and which bits we might be able to fast track or demonstrate weren't such a problem, or were just lower priority because of the real urgency of the situation we were working within. So we carried out a series of sort of proof of concept tests instead of the full set of regulatory tests that you have to carry out to be able to sell devices like this. And we've got a variety of them. We have a photo of one of them, so that with the respirator, video, with the respirator masks, we need to demonstrate that they fit appropriately. So there's a spray test, and this is me indeed in the same T-shirt. I've just realised this is our first spray test where we're testing the fit and I guess the air tightness of all parts of the assembly except for the filter inlet. So the idea is this is actually Paul Elkington whose idea it was to tackle this. He's spraying an atomizer, or using an atomizer to spray this bitter tasting solution into the air inlet. So I'll be able to taste whether anything is getting around the seals of the filter unit. We then turn the device off, and just to test that I can actually taste it, he's spraying it inside the visor, and you see how rapidly I have to get the visor off as soon as the taste comes through. So we used a test like that just to see. You see what a big deal that was. How happy a small test like that makes us when we pass it. We were fairly sleep deprived at this point, so a simple test like that, positive result, means a lot. We also carried out some tests to see the bacterial growth of or the bacterial load of any air which passed through the filter system. So putting Petri dishes inside the hood and outside the hood, and then passing a known volume of air over it, which had been filtered, and then incubating it to see what would grow. A sort of the other real key set of tests was those user feedback activities. So this is something that links very much to the research that we do. So I'm the mechanical engineer on the team in the prosthetics group, but we have some great social scientists and health scientists who are really good at actually asking people what they want from what you're giving them, instead of being driven by a crazy idea that the engineers have in a new toy. We're making sure that it's actually driven by what the users need. So for me, one of the most important parts was making sure that we were developing something that users in the hospital actually wanted. We're now moving on to doing more extensive regulatory testing, and Indo did a lot of work with the British Standards Institution to go for regulatory approval for the commercialised versions of these. So the Perso 3.0 is sort of in the final phase of regulatory approval right now. So it's not being used in the most high-risk version areas of the hospital, but the Perso 1, which is based on our original prototype, is coming along close behind. The pressure on the regulatory approvers means that things are taking a bit longer than we perhaps initially hoped for, but they've fast-tracked as much as they can, and I think we're quietly confident that the concept's working and should be providing some degree of improvement to the PPE that was otherwise available.
So I see that the time is running fast, although we'll ask you 100 million question. I'm going to ask just the last couple of questions before we open to more questions from the people attending the session. So you told about what was the past and the present of Perso, but what do you think is the future for Perso? And maybe Perso could be used in other environments. Before you show a picture of Indo Lighting with people working shoulder to shoulder on an assembly line, do you think it might be used, for example, in working places like meat processing plants?
Absolutely, yeah. I think that's one of the key examples that was given recently, where distancing at work is particularly challenging. I think in most recent news where you're looking at people working as beauticians and hairdressers and barbers, I think things like that where you need to have good visibility of the job you're doing, and you need to get close to somebody. It's important. I think for requirements of people like dentists and hygienists, it's important. We were sort of cautious about how we spread the idea at the beginning, because we wanted to share what we were working on, so we weren't competing. We could collaborate with other people, but we were also cautious that we didn't just encourage the public just to go and buy all of the fans and filters in the country, so that then the healthcare workers who really needed these things wouldn't have access to them. So I think sometimes it's about choosing where you really need a device like this, or where a mask is appropriate, and making sure again that if we're recommending people use something like this, that they've been trained properly, they know how to use it, and they don't actually elevate the risk to themselves.
So I'm going to ask you one last question, and then I'm going to open the question to everyone. So one question that we ask also in our first episode, and we ask to all the guests for the SOTSEF chat, what did you find the most challenging in the last 3 months on a professional, and if you want to answer us, on a personal level?
Gosh, so on a personal level, most challenging was learning how to use a sewing machine for the first time in about 20 years. On a professional level, I think the real challenge was that we were juggling a lot of the kind of ethical and regulatory processes alongside trying to develop something as fast as we possibly could, and so trying to bear in mind the fact we were working to a really urgent need. We had to test things properly, develop them the right way, and yet strike a sensible balance that meant that we didn't just spend the next year developing, by which time we have a vaccine and we haven't really helped anything. So a real challenge was making sure that compared to the teaching that we do on engineering design and the research we do on user-driven design for prosthetics, making sure that we were taking enough of those same kinds of considerations, that we were doing a proper job instead of just getting carried away, I suppose, by trying to come up with something too fast. Not the pithiest answer, perhaps, but yeah, I suppose trying to be true to our principles and yet deliver as fast as we could.
Great, thank you. So we have a few people attending the session, and would like to ask if anyone wants to ask a question to Alex. I'm going to wait a few more seconds. Yes. Yes. Ruth, if you want to ask your question, please feel free to turn on your webcam and microphone or write in the chat.
Excellent. Mine is about the businesses that you engaged with. Obviously, in the early days, there was lots of different people who were wanting to be involved and offer their services. How did you use your existing networks, and how did you choose the businesses that you would work with? Now, you know, like the filters, there's a range of different companies that offer filters of a similar standard, I would assume. How did you actually go about engaging with those businesses and developing that relationship to actually come up with a final design?
That's a brilliant question. One of the faces still on screen, I should point out, was Kerry Graham, who was from the Research and Innovation Services team, and she was a great liaison with some of the companies involved, as well as Alex Mance, who works for the Institute of Life Sciences, who gave us lots of support throughout the development. So they were real supporters, I think, in developing the company links that we moved forwards with. But along the way, several of us more sort of on the research or the technical sides of the project just had to reach out to people we knew of in our network. So, for example, McLaren and the sailmakers, Kemp Sales and North Sales as well. We were considering who we knew nearby, who had the expertise. From my point of view, I think the sailmakers are probably the best people to talk about, because I was involved in that hood development. I knew that I could only go so far with producing templates from flip chart paper and sellotape and then a cheap sewing machine, whereas you get to a point when you know we can prove the concept, we can show this to people and get feedback in principle. But there's a point at which we have to accept that other people are going to be able to transform the design in hours and start prototyping and scaling up in minutes, where it takes me half a day to produce something. So reaching out to sailmakers in particular was key, and then I think similar approaches for the 3D printed parts of the prototype headgear, for example, that McLaren helped us with. It's a case of recognizing where the limitations in our expertise were, and the right time to start asking for help.
Thank you.
Thank you, Alex. I think we have time for one last question, if anyone wants to ask anything else. If not, I'm just going to ask something very briefly before we say goodbye. And as you mentioned before, talking to people on social media. So how was PERS in general received? What was your perception of how PERS was received from the general public? And did you have any useful contribution from the public itself? Because before you mentioned obviously people in the hospital, you mentioned companies as professionals, but what about the general public?
So we've had a real range of responses, but generally people have been enthusiastic and spurred us on. And I think what has been useful has been people helping us to identify the strengths and the scope for improvement in the concept. So the fact that you can see the wearer's whole face seems to be very well received, and quite apart from the fact that we obviously communicate quite a lot with our facial expression, especially for people who have hearing difficulties and need to lip read, but then heard more about requirements to help the wearer be able to hear better themselves. So looking at different hood designs that are off the ear, so that people can wear a stethoscope at the same time as being protected. We've had a lot of feedback on Twitter. Some people pushing us on, and others saying, well, yeah, I've been welding in one of these for 20 years. And I think that's just encouraged us to make sure that we communicate as carefully what is different about this and what is established and well understood.
Great, thank you. So I think our 30 minutes are off. It was lovely hearing from you and to know a lot more about Perso and the story behind it and what's next. And I would like to thank you once again for joining us today for the SOTSEF chat. And for people that are still connected with us, we have a last episode coming up next Tuesday at 3 p.m. with Dr. Carrie-Anne Harrington that will talk again a bit more about PPE and PPE shortage, but with a completely different story of community involvement and 3D printing in maker spaces in Southampton. But once again, thank you very much, Alex. It was lovely talking to you, and thank you very much for attending our session today. Goodbye.